Hello guys, this is Christine and today I will give you guys some more help for organic chemistry. Today the topic we're going through is stereospecific product. So what is stereospecific product and when does it happen and how to predict and how to draw a stereospecific product. So let's get started. For stereospecific product, is mean that there's only one product form. There's no major or no minor product because there's only one specific product form in the reaction. So there's no major and no minor. That's why we have the word stereospecific. Specific is mean that only one specific product form. Second is that the stereospecific products only form in E2 reaction. We don't have stereospecific in E1 reaction because in E1 reaction we always have Zicef and trans favor products. So in E1 we always have Zicef and trans favor product. We don't have stereospecific product. So stereospecific product only occur in E2 reaction. And next we have I see that usually in E2 we will form Zicef product. That's why I have stereospecific, because the more substituted it is, we can see that it has stereospecific. Like we can kind of like see it, but in some case maybe you still have Hoffman product. This point is not really important, but I just want to leave it here so you guys can have a little bit more idea. And also that we have when stereospecific product only form when there is only one hydrogen in the beta position. So there's only one hydrogen in the beta position. So if you guys see and notice that two hydrogen on the beta position, this never ever form a stereospecific product. So in order to form a stereospecific product, we have only one hydrogen in the beta position. And not only one hydrogen in the beta position, but also that this hydrogen and the halide must be in the anti-periplanar configuration for the reaction to occur. So this means that the hydrogen can be on dash, one can be on wedge, or otherwise. But I will provide you guys some more tips on how to draw it. So in general, in some that stereospecific product form in E2 reaction, that's the first thing. The second thing is that when there is only one hydrogen in the beta position. And the third thing is that the hydrogen and the halide must be in the anti-periplanar configuration for the reaction to form. So those are the three characteristic and three factors when a stereospecific product form. And also we notice one thing, as we know it, the characteristic of the stereospecific product, that there is only one product form. And this product, I want to add one more thing, is that this product can be trans. It can be either trans or it can be either cis. And there's no favor here because it depending on the configuration, the configuration of the reactant. So stereospecific, the two characteristics of it is that there's only one product form in the reaction. There's no major, no minor. And the second thing, that this product can be in trans or can be in cis. It can be trans on cis configuration. And depending on the configuration of the reactants. However, we notice that in E2 reaction or in not stereospecific products, we have major products, we have minor products, we have more than one product form. And usually if we have two, major and minor, the major would be trans. It will favor more than the cis product. And it does not depend on the configuration of the reactant. But this is the opposite to the stereospecific product. These are the two characters that you want to remember. So let me zoom out so you can take some notes that you want to take. Alright, so let's go through some example to understand more about stereospecific product. So here are the two anti-periplanar configuration that I kind of want you guys to see. Sorry that I'm using my phone to record, that's why it is a little bit slippy. So here we have the anti-periplanar position configuration is when we have the halide, in this case the bromide, and the hydrogen. These are in opposite. It is in opposite position. So this is called anti-periplanar. This is called anti-periplanar configuration. When bromide and hydrogen is in opposite, it kind of like in opposite in the Newman projection like this. This is a Newman projection, and bromide and hydrogen kind of like in opposite position. And you see that how hydrogen is the only one hydrogen in the beta position. So this and this is actually the same, but I just want to kind of like, this is the Newman projection, but this is the wedge and dash configuration. But these are the same. So we see the bromide and hydrogens in opposite position like this. That's the first thing. And the second thing that we see hydrogen at the beta position is the only hydrogen in the beta position. This is the alpha position, the one that connected directly with the bromide is the alpha position. And this is the beta position, the position that connects indirectly, and it connects with the alpha position. This is called the beta position. And in our beta position, we have only one hydrogen. This signifies that this reaction, this is the problem. Maybe that can be one of the reaction involved in E2 reaction with stereospecific product. So let's go through some example so we can understand better. And also I have this notes. Maybe we can go through that later. So in another case, that in a ring, when we see a ring, then the hydrogen is really clear, the hydrogen and the halide is really clear to see if the reaction occur or no, because the hydrogen must be on dash, then the halide must be on wedge, or vice versa. If the hydrogen on wedge, then the halide must be on dash for a reaction to occur. If either of this happen, then no reaction occur. So let's go through some example for this. For example, say we have this. What do you guys think? Feel free to pause the video if you want to figure out the product. So in this case, for example, if I go through NaOH, right? NaOH is a really strong base, and it's a small base. In this case, I will consider, for example, we assume that I want to see the E2 product. So for E2 product, here's my alpha position, right? The one that connect directly with the bromide, and here are all the two beta position. So now looking at these, I want to figure out which hydrogen will I take. So the hydrogen I can take is that if my bromide is already on wedge, I want to react with the hydrogen that is on dash. The hydrogen on wedge cannot occur because wedge and wedge are not in anti-periplanar configuration. So the one that might be one on dash and one on wedge will occur. So in this case, I have this hydrogen and this bromide on one on dash, one on wedge. So for sure, the reaction will occur. However, this hydrogen never involved in is on wedge, and bromide is also on wedge. So this hydrogen does not occur and involve in the reaction. E2 reaction. Only this hydrogen, one on dash and one on wedge, can occur. And the second one is that this hydrogen, what about this hydrogen? Do you think is involved in the reaction? The answer would be yes, because this is a wedge and this is a dash. So the one on wedge and one on dash, so this will also occur in the reaction. Alright, so if we say the product, we have two products. we have two products. In this case, seeing it's a ring, so seeing it is a ring, so I don't really can say that they have only one product. So let's see. So after it reacts, we have this product. This is a product, and CH3 here does not involve in the reaction, so it still keep as a wedge. And another one is here. And another one is here, right here. And since this is involved, so now this is come back to carbon sp2, because carbon sp2 is not a chiral center, so I cannot draw a dash or wedge here. That's why this come back to just a line. So these are the two products that I can form from stereospecific product. In the case of the ring, you may have more than two, so remember that. So in this case, I mean, you can have more than one product in this case of the ring. So, but in this case, which one is the major product? The major product would be this one. Why? Because this one is the tri-substituted. It's more stable and is a major product. However, this one is a di-substituted. So this one is a minor product. So if they ask you what is the major, this one will be the major product. However, we can see that these two hydrogen both can involve in the reaction. Alright, so let's move on to this one. This one we have this is the alpha position, and also we have this as beta position. So in this case, let's figure out what hydrogen in the beta position cannot occur and involve in the reaction. So in this case, if I have this dash on the methyl, then I have the wedge must be on the hydrogen. And also in this, I have the methyl on the wedge. So my dash must be on a hydrogen. So now I already filling my hydrogen. Now look at this. I have my bromide. My bromide is a wedge. So it can only react with the hydrogen on a dash. So in this case, if I look at this, I can see that my hydrogen on this beta position is on a wedge, and my bromide is on wedge. This is not antiperiodic planar, so no reaction occur on this hydrogen. However, this hydrogen, we have this hydrogen on a dash, and this bromide is on a wedge. So these are antiperiodic planar. So there is only one product here occur, and it is stereospecific, and only this hydrogen can involve because this hydrogen and the bromide is on antiperiplanar. So if I draw this, the CF3 still keep the same because they're not involved in the reaction, so it's still a dash. And I have this, and since this is this carbon converting to carbon sp2, so there's no chiral center, so this is just a line, no dash, no wedge. So this is the only product that I have. This is the only product that I have for stereospecific product. So this video is a little bit too long already, so I'm gonna stop right here, but I'm gonna make another video to show you guys how to do these two examples, and I have some tips and some notes of how to draw stereospecific product also. So I upload another video for that. Thank you for watching the video.